In 2023, astronomers found something that shouldn't be there. A supermassive black hole in the early universe. So massive, it breaks the timeline of cosmic growth. The object is called J0313-1806. It existed when the universe was just 670 million years old, less than 5% of its current age. And its mass? About 1.6 billion times the mass of the Sun. That's not slightly large. That's fully formed monster-level large. And according to our models, it shouldn't have had enough time to grow. Black holes don't just appear at that size, they grow. They start as the collapsed core of a massive star, maybe 10 to 100 solar masses. Then they accrete matter. Gas falls in, stars get swallowed, they merge with other black holes. But growth has a speed limit. It's called the Eddington limit. If matter falls in too fast, radiation pressure pushes it away. So black holes grow steadily, not explosively. At that rate, reaching 1.6 billion solar masses should take far longer than 670 million years. Yet this one did. So either it started much bigger than we thought possible, or it grew in a way we don't understand. Let's rewind. The first stars formed roughly 100 to 200 million years after the Big Bang. Those stars lived fast and died young. Some collapsed into the first black holes. That leaves, at best, about 400 to 500 million years for growth. That sounds like a lot. Cosmically, it isn't. To grow that fast, this black hole would need continuous feeding, near perfect efficiency, no long dormant periods, possibly super Eddington accretion. And even then, it's tight, very tight. Some simulations can barely make it work, others can't. There's a more radical idea. Maybe the first black holes didn't form from stars at all. Maybe enormous gas clouds collapsed directly into massive black holes, skipping the small seed phase entirely. Instead of 100 solar masses, start with 100,000. That helps. But even that requires very specific conditions. Extremely low metallicity, suppressed star formation, special radiation environments. In other words, rare. And yet, we're finding multiple massive early quasars. Not just one. This isn't just about one object. Supermassive black holes sit at the centers of galaxies. They influence galaxy formation. They regulate star formation. They shape large-scale structure. If black holes formed earlier or faster than expected, galaxy evolution changes. If the timeline shifts, our understanding of structure formation shifts. And that connects to dark matter, to early density fluctuations, to inflation. One object doesn't rewrite cosmology, but several anomalies. That starts to apply pressure. There's another possibility. Our early universe assumptions might be incomplete. Maybe black hole growth physics changes in extreme environments. Maybe primordial black holes formed from density fluctuations shortly after the Big Bang. Maybe there are growth mechanisms we haven't observed locally. Or maybe we're underestimating how violent and chaotic the early universe really was. Because here's what makes this powerful. This black hole isn't slightly off. It's billions of solar masses too early. That's not a rounding error. That's structural tension. Cosmology works extremely well. The cosmic microwave background matches predictions. Large-scale structure matches simulations. Expansion fits ΛCDM beautifully. But precision cosmology is now finding edge cases. Objects that exist earlier than expected. Structures that appear more mature than predicted. Black holes that grew too fast. Each one can be patched, adjusted, explained. But science advances when pressure builds. And sometimes Anomalies aren't noise. They're signals. Signals that something deeper is incomplete. Somewhere in the early universe, less than 1 billion years after everything began, a black hole was already massive enough to power a quasar brighter than entire galaxies. It shouldn't have had the time. But it did. And the question isn't whether it exists. We've measured it. The question is, what did the universe do differently that allowed it to form? Because when something grows too fast in cosmology, it means either the universe was more efficient, or our understanding is slower than reality. And right now, reality is ahead.